Next, we are going to introduce the Conversation AI template. First, let's watch the Conversation AI in MR video again.
Hi. Hello, how can I help you today?
Help me pick a random number from 1 to 10.
Sure, here's a random number. 7.
你可以跟我用中文交谈吗？
当然可以，你想聊些什么呢？
The structure of this template works like this. First, it starts by taking in audio input through the audio system. Basically, it listens to what the user is saying using a microphone. Next, that audio is processed and converted into text using speech-to-text technology. After that, the text is sent to the conversation AI system, which communicates with the GPT-4 or Mini API to generate a meaningful response based on what the user said. Finally, the reply from GPT is used to drive multiple things. It triggers the avatar's animation, syncs the lip movements to match the words, and also plays the voice output so that avatar can respond naturally to the user. This intro flow allows for real-time interaction between the user and the avatar, creating a smooth and engaging conversational experience. These are the objects related to the avatar. An audio recorder is the system that detects the analyzed voice input. It listens to the microphone input in real time, and based on what is heard, it figures out when someone is speaking. There are several parameters can adjust. VAD stands for Voice Activity Detection, since we need to continuously listen for voice input. We are using VAD mode for the listening mode. Sample rate refers to how many audio samples are collected every second and is measured in hertz. In simple terms, it tells us how frequently the audio system is capturing sound data. For example, a sample rate of 16,000 Hz means the system collects 16,000 tiny pieces of audio per second. A higher sample rate gives you better sound quality, but it captures more detail in the audio, especially important when you want voice to sound clear and natural. However, there's a trade-off. Higher sample rates also mean more data is being generated, which leads to larger file size and possible more precise load. So when choosing a sample rate, you are balanced between audio quality and system performance. Interrupt response on new recording is pooling time. It controls whether to interrupt the current voice playback when a new recording starts. The VAD energy threshold is a setting that controls how sensitive the system is when detecting whether someone is speaking. This threshold tells the system how much audio energy or volume is needed before it considers the input as actual speech instead of background noise. If the threshold is set to low, the system might pick up noise and think it's someone speaking. On the other hand, if your environment has a lot of background noise, you might want to raise this threshold. That's why only louder, more intentional voice input will be detected as speech. VAD silence direction is a setting that tells the system how long it should wait the wrong silence before deciding that you are finished speaking. It's measured in seconds, and it works like the VAD system to know how to stop recording. For example, if it sets to 1 second, the system will listen for silence, and if you doesn't say anything for 1 second, it assumes you are done talking and end the recording. This is useful for making sure that the system doesn't cut off too early while you are still thinking. The VAD frequency threshold is measured in hertz and is used to control a high-pass filter. What this means is that it blocks out any sound frequency that you are lower than the value you set. Since a lot of background noise, like air conditioners, low rumbles, or mic hum, tends to be in lower frequencies. Setting this threshold helps reduce this kind of noise. By filtering out those low, unwanted sound, the system can focus more accurate and on detecting actual voice input, making your voice detection cleaner and more reliable, especially in noise environment. Since both the lip sync system and the audio player need reference data to function properly, they rely on something called the FFT sample size. FFT stands for Fast Fourier Transform, which is a method used to break down audio into different frequency components. This is how the system knows that the audio sounds like. For example, which parts are high pitch, low pitch, loud or soft. The FFT sample size determines how many audio samples are analyzed at a time. When the sample size is larger, the system gets more detailed information, which allows it to create more accurate and natural looking lip sync movement and better sounds audio playback. However, there's a trade-off. Using a bigger sample size means it takes more time to process the data, which can introduce a slight delay. So, depending on your need, you might want to balance between detail and response. The audio player in audio game object is used to play the voice. The audio player in lip sync audio game object handles the lip movement. Since meta-sync systems sometimes block sound when the avatar lips are moving, we used to separate audio source to play the voice and handle lip sync at the same time. And just like we mentioned earlier in the recording section, sample rate is the number of audio samples played per second. FFT sample size is how much reference data audio and lip sync audio need to get from the end. The real-time API wrapper is the part of the system that manages communication with OpenAI real-time voice conversation API, specifically the GPT for a real-time API. When a user speaks, the voice input is first captured and then sent directly to the API through this wrapper. Once the API receives the voice input, it quickly processes the audio and sends back a text response, which represents what the AI wants to say in reply. The wrapper doesn't just stop there. It also takes care of handling what's response. It plays back the AI voice so you can hear the reply. And at the same time, it triggers the lip sync system to match the avatar's mouth movements with the spoken audio. So in short, the real-time API wrapper is the key system. Let's tie everything together. Capture voice getting response and handle both audio output. Using an open AI API key provided by us and they use usage limit. We will post an announcement with the OpenAI key details on E3 after class. When you press the play button, you will see the setting panel in the scenes. After press the connect button, the system creates a section for real-time API. This is another way to connect to OpenAI. It uses a different API channel that's simpler and text-based. Instead of dealing with audio input, you just send a plain text string as a prompt, and the API sends back a text-based reply from the language model. You can easily test it by calling the GPT request.sendPrompt function in your script. This function sends your text to the LLM. To see the reply, you can check debug.log. It will print out the response right in the console, so you know actually what the model is saying. This method still requires an OpenAI API key, which we will provide. When running, you will see the conversation transcription panel appear next to the avatar. The icon in the top right shows the volume level of the incoming audio, while the center displays the LLM response text. You can scroll through the panel by swapping directly on it or by using a pin gesture. We have assignment tool for this template and it's a personal assignment. This assignment is all about making your avatar response intelligent based on what the real-time LLM says. So first, you will need to connect your system to the real-time LLM, which will generate replies based on what the user says. Then your job is according to those replies and create appropriate response from your avatar. That means you won't just play one generate animation. You will need to show that your avatar is actually reacting to the content of what's being said. To do this, you will replace the default avatar with your own character model. Then you will add at least 3 different animations, such as nodding, waving, or reacting emotional. That animations must be tied to specific conditions based on the LLM reply, not played as random or played as voice command. For example, if the LLM gives a happy reply, the avatar might clap, or is confused or asks a question, maybe the avatar raises an eyebrow. The goal is to make the interaction feel more natural and meaningful, just like a real conversation. Advanced parts, you can add more animation and based on the LLM replies, then switch other things like object, UI, etc. based on real-time LLM replies, not just animations. And you can also include more avatars to make the interaction richer. Next, we also welcome to add any other fun ideas you come up with. Your submit ZIP file should include a PDF report explaining what you did and how you did it, and a video demo of your design. Keep it under 3 minutes. Upload it to YouTube and include the share link in your report. Since E3 has a file size limit, please zip your full Unity project and upload it to a cloud drive. Then include a share link in your report so we can download it. Make sure everything runs properly before you share the link. Here's how the assignment will be graded. And if you submit late, there's a 5% deduction from your total scores for each day is late. Also, if you missing any required file or link, it will be counting as a late submission too. There are the assignment hints. You can grab the reply text directly from the real-time API wrapper scripts. These scripts receive the voice response from the LM and also make the text version available for further precision. Second, you take less text and pass it into the send prompt function instead the GPT requester script. This function is designed to forward the LM response as a prompt into another GPT code, which can be used for decision making. Third, in the GPT request script, the update function continually checks how new replies. When it detects a response, it analyzes the content and decides which animation should be triggered on the avatar. This allows the avatar to react intelligently, not just respond with audio, but actually changing behavior based on what the LM says. This assignment deadline is on Monday, May 12th. And next, here are the reference for this template.
Right, so this is basically the requirement for the assignment 2. Just a recap, you will be working on a conversational agent and be able to talk with the agent. These functions are default in the template version, so you don't need to do anything. The template version already allows you to talk with an agent. But what you have to do in this assignment is that you would add custom animation to the avatar. And that animation, which means that the avatar's reactions in the dialogue supposed to be made kind of intelligently. So like the animation that you add, not limited to 3, but at least you have to add 3 different animations that could trigger by dialogue. Means that it's not voice command. It's not that you demonstrate, okay, a jump and the avatar jump. It's not what we want to see. We want to treat the avatar as a natural person because it has intelligence. It's supported by OpenAI. It can talk with you intelligently, just like a human. So try to add animation to the avatar so that it reacts to your conversation, not react to your command. Right? So this is the key that we wanted you to do, and the key that we evaluate how effective that you achieve the goal for the assignments. Technically, this is not like to any aspect a technical assignment. You know, just most of everything has been set in the template project. That very detailed thing you already get this 60% upgrading. So the basics is quite easy with the report, but what we want to see is how you design the making of the avatar animations to what we expect from the dialogue. For example, you can do like mapping the happiness in the dialogue to the animation. Like from the LLM, you detect the dialogue from the aspect of the avatar. Listening to that dialogue, he detects that this now the dialogue is in a certain level of happiness, right? Or energy, could be the energy level. You just ask, for example, ask the LLM to kind of measure what is the happiness level in the conversation that is going on. If that level, like you can say, like let's have the happy level divided into 4 discrete levels. And you just ask LLM which level you think our conversation been going on. And if they say like the happiness level is pretty low or energy level is pretty low, and you might launch a corresponding low energy avatar animation to just reflect how the avatar felt the conversation going. This is just one example, but you can find your own mapping, like you can map like the happiness, sadness, or like upset, or like the noise level, or like what this is your code. It's your code. Like try to make the demo. But like make the video looks interesting. And what you have to show in the video for the 3 minutes video submission is that you're gonna record a dialogue of you with the avatar. Using your own language is fine, like English or whatever language, or like any language you're comfortable to have the conversation with the agent and with the conversational agent, right? And make the dialogue somehow showcase those animation setting, with the avatar, the linkage behind that you designed. This is basically the requirement for the assignments. Again, it's not a technical assignment. It's mostly like getting everyone hands-on the avatar interactions. This is what will be very foundation for when we're moving toward the final term project. Okay, so